HPE Aruba has a unique position where we've got exclusivity with a technology that no one has. And we're going to be talking about that and what that can bring to your company and your environment. And my name is Tom Grover. I have been with Aruba for about 8 years, and we have a distinguished panel of guests here from both our partnership with AMD Pensando, HPE Aruba, and our platinum partner in HPE Aruba, Garrett Law, who is a sales and engineer there. So, Tony, could you introduce yourself real quick in your role, and then we'll go around the horn?
Yeah. Hi, I'm Tony Lowe. I'm a data center network specialist with HPE Aruba. Been with the company since 2019, and glad to be here.
Scott.
Hey, I'm Scott Stevens. I'm the field CTO for AMD Pensando. Been part of the Pensando group for about 4.5 years. We were acquired by AMD about 2 years ago at this point.
And Garrett.
Yeah, my name is Garrett Law. I'm a technical account manager and senior network architect with Zunesis. We're an HPE Platinum partner and reseller. I've been at Zunesis for about 5.5 years.
Thanks, fellas. So, as I mentioned, we have this unique technology that no one else has right now, which brings us into the next evolution of switching architecture. And so, Scott, I've heard you often setting the context around HPE Aruba and AMD partnerships around what you can expect in the next or the fourth generation of data center networking fabrics. Can you unpack what this means?
Sure, happy to, Tom. Well, I think if we think about how we build data centers, it changes fundamentally about every decade. So if you go back into the 90s, we used to build layer 2 switched networks because that's all the silicon could do, and we had a lot of protocols we were dealing with back then. IP, IPX, DECnet, AppleTalk, Banyan Vines, all kinds of crazy protocols. And so we built layer 2 switched networks, which worked, and all those protocols could coexist at the same time, but you had all the fun of spanning tree, and you didn't get a lot of bandwidth up towards the core of the network because spanning tree would cut off any redundant links. So around 2000, two things happened that fundamentally at that point changed how we built data centers. The first was IP won the battle, and so we didn't have to deal with all those other protocols. They were rapidly dying off. But more importantly, silicon, since it could focus on IP, we now built switches that could route at the speed of switching. We no longer said switch when you can, route when you must. Around 2000s, you could now route at the speed of switching. So we built layer 3 switched data center backbones, which were wonderful. We could have multiple uplinks. We could have very fast recovery using protocols. We didn't have the 30 to 45 seconds of recovery using spanning tree. We got much more efficient in how we built things. And that went on for about 2010, when VMware and others came along and they fundamentally changed how applications hosted in the data center. And as we know, the data center fabric, the network, has to serve the application. The workload is king. And so when VMware came along and virtualized everything, we fundamentally now started to look at how we hosted workloads in the data center differently. It used to be, in those first 2 generations, if you had a big app, you bought a big server. You had a small app, you bought a small server. So you kind of had one app per server. And all the flows in and out of the data center were north-south. Right? The user request would come into the server, be processed, and go back out. In that third generation, in the 2010s, as we virtualized everything, now if you had a big app, it would go across 20 servers, or if you had a small one, you could put 20 on the same server as everything was virtualized. And what that led to was first of all, some new requirements in how we did networking. Because these VMs now had the ability to move around, we had to extend layer 2 boundaries and across layer 3 borders that we didn't have to do in the past. And so we invented VXLAN and EVPN networks. And we started to build the ability to distribute layer 2 across different segments to support this virtualized environment, which was wonderful, but it started to lead to complexity in how we actually built the fabric itself. And it also led to an explosion of east-west traffic, where apps are talking to apps in the data center instead of just users and apps transacting north-south in and out. And as that happened, new breakdowns occurred in the fabric. So now, because we have east-west, which we didn't really have to deal with before, we started thinking about, do I need to secure how these apps talk to each other? Is that a point of vulnerability? Or do I need Do I need telemetry or visibility to how these apps are talking and who's talking to who and how much and how are things performing, and do I have any network performance issues, or do I have encryption needs? Do I have NAT requirements? So all of these new requirements came along with this explosion of East-West. And as all vendors do, every time there was a new breakdown, a vendor came along and said, we know how to solve that problem. And they fixed it. And then a new vendor solved the next problem, a new vendor solved the next problem. And the next thing you know, you've got a data center with a dozen operating systems between switches and firewalls and probes and agents and whatever else. And you've got a lot of complexity to manage trying to stitch together all of these workloads transacting with each other. Now, in the same time frame, around the 2010s, the hyperscalers looked at this architecture and they said, we're building the world's largest data centers, right? Amazon and Azure and Oracle and Google and everybody are building these massive data center cloud infrastructures. And they looked at that architecture and they said, no, that's not going to work for us. If we're going to build these massive data centers, they have to be simple, right? And that means fundamentally that this fabric that we built in those first 3 generations, which was a stateless fabric, right? Switching has always been stateless. It's been plumbing. And then we bolted on these stateful functions in that 3rd generation. Hyperscalers said, that's just going to be part of the fabric. It's going to be fully distributed. And we're gonna roll that out across our infrastructure. So they're going to build a stateful fabric with a single operating system to do all of those functions required between workloads, be it connectivity or security or telemetry or encryption or whatever it might be. Well, that was never available. So for a decade, the hyperscalers have been building the world's largest, most scalable, most resilient data centers in the world. And the enterprises haven't had access to that until now. And so the DPU technology that's embedded in the Aruba CX10000 is a technology that comes from the hyperscalers, right? It's deployed in Oracle Cloud. It's IBM Cloud, Microsoft Azure. It is a hyperscaler-based stateful processing unit that can do all of those things that I just spoke to in now this 4th generation. So in the 4th generation, what we're trying to solve for is fixing all the complexity of the 3rd generation. We still need connectivity, we need plumbing, but we also need stateful services, we need telemetry and visibility, we need encryption. All of those things have to happen in the fabric as close to the workload as possible. The 10K is now a completely unique stateful switch that is able to do what the hyperscalers have been able to do now for over a decade, but finally now delivering that same simplicity, that same performance, that same scale for any any enterprise customer in the world who would like to leverage this technology and get that same simplicity that the hyperscalers have had access to. So Tom, it's a pretty long answer, but if you think through the history of how we change every decade or so, we're slightly overdue, right? It's 2024, and we're now, we're 3 or 4 years behind the curve in updating how we build data center networks. And the 1st gen was a little complex, 2nd gen made it simple, 3rd gen was ridiculously complex. The 4th gen's purpose is to make it simple, make it scalable, make it performant, make it lower cost for our customers to reduce everything down to a single OS. The fabric is now going to be run by CXOS.
Yeah, so Scott, can you tell us exactly what problems those address for customers?
Well, there's several that are very, very interesting. I think as we look at how we can simplify that data center fabric, the first that Tony mentioned, of course, is microsegmentation. The microsegmentation has been challenging, a lot of it due to the form factor of security appliances. And being the top of rack, we're in the right place to inspect all traffic. And so we have the ability to be an incredibly scalable east-west firewall within the data center. But while that's critical and while that's a great value add, the place that I've been spending most of my conversations recently with a lot of our customers is simply around visibility and telemetry. One of the things that the 10K does very, very powerfully is provides complete visibility to every flow in the data center, both north, south, and east, west. And with that visibility, we now have a time machine. We can see everything that's happened in the data center. And if there's a problem, we have the telemetry from when the problem occurred. That hasn't been the case in most data centers through the 3rd gen, right? We've inserted probes or we've put agents in or we've tried to tap networks to get access to traffic to try and figure out what went wrong, typically after there was a problem. But with the 10K, we have all the telemetry all the time. And so we know exactly what happened and when it happened, and we can troubleshoot and isolate and figure out what's going on. But more interestingly, with that telemetry, we actually have the fuel to feed AI ML engines, right? We have the ability to engage in AI operations, which, by the way, is something the hyperscalers have been doing for over a decade, right? Why do hyperscalers have the world's largest data centers, but they don't have the world's largest NOCs and SOCs? Because they automate like crazy. And to automate a running network, you need to know what's happening in the network, which means you need all the telemetry. You need to understand, not at just the network level, but at the application level. You need to understand everything that's talking to everything else and all the flows that are happening in the data center. If we can feed that into the right AI ops engines, we can now automate the data center. We can have computers solving people problems, right? And figuring out all of the challenges, find an outage that's going to occur tomorrow and deal with it today. We can do these things now because we have the telemetry to feed into these really, really interesting AI-based tools, and that world is exploding. The tools that are happening in that side of the business and the SaaS-based offers that we're seeing in the marketplace is fascinating. So having a network that's rich enough and capable enough to feed those tools creates the opportunity to automate the data center, to reduce the human burden, and let the humans focus on the really, really hard problems. Let the computers get rid of all the noise and all of the normal challenges that we see. So, to kind of sum it up, microsegmentation, absolutely. The 10K is very powerful with that. The ability to encrypt and NAT between locations, data center interconnect or cloud interconnect, unbelievable what we can do there in terms of performance and scale. But having full visibility and full awareness in the data center fabric where I don't need probes, I don't need agents, I don't need to tap to find it. I know it all the time, everywhere. I have the telemetry from when the problem occurred. That's a game changer for a lot of our customers, and that's really changing a lot of conversations in the market today.
So can you take that and elaborate on some specific use cases?
Well, yeah. So if we want to think about network-based AI ops, the ability to feed that telemetry to tools that now become application-aware AI ops tools in the network, so that we can now see and understand at an application level are they working properly? Are all the applications transacting as they're supposed to, or do we have any issue that's happening between those apps? And then quickly diagnose. Because if two apps are having troubles talking to each other, it could be an app issue, it could be a server issue, it could be a network issue. That's, the networking team is always blamed whenever there's a problem between two workloads. So mean time to innocence, the ability for a networking team to prove that they were innocent is critical. With that full non-sample telemetry for every flow in the data center, we now have the ability to quickly correlate and understand if these two apps are having a problem. Is it an app problem that the receiving app is buffering or having challenges, or maybe it's got a software glitch or whatever it might be? The server's overloaded, I've got too many apps running on the server. Or is it a network problem? Do I have congestion happening in the network that's causing problems between these two? But because we have all that telemetry and we have all the insights that comes from CX and all the telemetry that comes at the app level, we can now immediately, through these AI ops integrations, correlate that and understand, I've got an app issue or I've got a network issue. How would it be for the networking team to call up the app team and say, you've got an app problem? The network, by the way, is fine, but we've already seen that you have a problem between two of your workloads and you need to deal with that. That's never happened, right? It's always the other way around. The app team's always calling and yelling at the networking team. But with the 10K, we now have the ability to flip that, which in the end, instead of pointing fingers, what it means is we can have a far more resilient, far more capable network, because we're no longer ships in the night where app owners are looking at the network as this plumbing transport stupid thing. They're now collaborating with each other and they have insights into each other. So these tools can be valuable, not just to the network, to the NOC and the networking team, but to the app owners and the app teams. These are the kinds of problems that we can solve. Just thinking about visibility and telemetry and AI insights, these aren't solved today, right? These are very, very manual processes with lots of moving parts and lots of disparate tools, all that have a different view of what's going on in the network, while the networking team is trying to prove MTTI, like, are they innocent? All that goes away when we actually have the knowledge and all the insights and all the telemetry. That all goes away and we actually deal with the fundamental problem instead of finger pointing.
I'd also like to add, excuse me, I'd like to also add that K solves a lot of these problems and issues at a economic scale that is really kind of mind blowing to the customers, right? So these problems that Scott's talking about that they're trying to solve are very complex and they're often quite expensive. So to gather the telemetry that you need for a large network, customers may deploy something like ExtraHop or some agents to actually gather the telemetry. Well, the licensing model for those agents are incredibly expensive, right? And we could save customers, if it's a large customer, orders of millions of dollars, in terms of agents, and deploy something that's much simpler to actually execute. Having that ability to deliver that type of capability, the telemetry in the switch itself, instead of managing agents and managing software codes and what have you, the cost economics are really quite tremendous. Same thing happens with East-West firewall, right? Similarly with agents that run for the purpose of providing firewall capabilities between your VMs. And that use case with VMware, of course, is a tremendous opportunity for the CX10K, especially with regard to the recent Broadcom price increases.
So you mentioned licensing, Tony, and I want to bring Garrett Law into this from the partner perspective, because I think there are some things going out there in the marketplace that Garrett may be seeing regarding some, changes with certain companies and acquisitions and licensing. So, Garrett, what are you kind of seeing out there, and how can this solve some of those situations that customers are seeing?
Yeah, certainly. Thanks, Tom. So, as we all know, right, the change in Guard with regards to VMware and how their licensing is working is definitely displaced a lot of people. A lot of people found out overnight that they can no longer afford the infrastructure that they've probably been running for a decade. That's one use case, and again, that's anecdotal, but it happens quite frequently. The other thing is, I think that the departure from doing east-west firewalling on a more traditional monolithic firewall, I think that you can save a lot on your firewall spend, right? I mean, I think putting the firewall, layers 4 through 7 at the top of rack really kind of changes what you can do architecturally, and lessens the necessity to spend $100,000-$200,000 on a perimeter or intermediary firewall. So it's a big game changer. I think that it can displace a lot of existing products in the market that currently exist. I won't name names, but I think it's a different approach, and I think it's a more sensible approach. I think that AMD and HPE Aruba really are taking this and making people step back. I know that when I first heard about the CX10Ks, I was like, wow, that's a different way of thinking about it, right? That's a different way of solving that problem. And like Scott said, it's logically the right place to solve that problem, right? Why would you buy a monolithic firewall, to do your east-west microsegmentation, or invest in, NSX or other, host-based firewalls out there, when the traffic flows are right there? They're right at the top of the rack. It seems redundant and overspending when you do it with a firewall.
Thanks, Garrett, from that perspective. So, Tony, can you tell me then how the licensing works on the HPE Aruba 10K?
Absolutely. So as with all the CX platforms from HPE Aruba, we don't have any additional charges for advanced protocols. So VXLAN, EVPN, BGP are all inclusive within the base OS, and there's really no fee for that. Well, the CX10K, we've actually have 2 licenses for the advanced services of the DPU. So we have our advanced license, which provides for the layer 4 firewall capabilities and telemetry. And if high-speed encryption and NAT is required, there's the premium license, which is on top of that. So those are the 2 available licenses.
So the base license, Tony, solves everything I've been talking about from a telemetry and microseg perspective within the fabric?
Absolutely.
Thanks, Tony, for explaining that. And can you, cite any public examples around these customer benefits that you've just mentioned?
Oh, absolutely. There were quite a few use cases. We have one very large customer that we have, DXC. They are basically a hosting company, and they have a very interesting requirement for multi-tenancy. And this speaks to basically all the features that the CX10K can possibly deliver and the value of that. They projected they probably saved something like 70 to 80% of their new data center builds using the CX10K instead of traditional firewall capabilities by being able to terminate VPNs onto the CX10K and offering high-speed encryption, and also being able to perform the macro segmentation on the backside to be able to separate the customers' applications. And of course, from there, the possibility is to bring it into the host environment and offer east-west segmentation and macro segmentation within their own hosting centers. So that one is just tremendous. That one is a almost direct takeout against the firewalls. Instead of terminating all those services on the firewall, you terminate them on the CX10K, much lower cost economic. So that use case in itself offers some really, really high payback. But not all applications need to be sold at large multi-tenant hosting facilities. I spoke with a lot of school districts and a lot of other state and local governments where we have a smaller scenario where we can deploy the CX10K in something of a collapsed core architecture and still provide direct server connectivity and provide that kind of firewall capability and deliver macro segmentation. You terminate those the VLANs, the switch virtual interfaces on the CX10K, take them off the firewall, and you consolidate security and network, and you provide the customer a very clean path to do so. Another circumstance is a VMware case. There's a school district that basically had their VMware licenses terminate, their contract, the perpetual licenses terminated on short order, within months. And there's a mandate to actually deploy some sort of firewalling for their VMware environment. Their only choice they had at the time was to go to NSX and VCF, and their cost model with VMware shot up literally 300-400%, and it blew their VMware budget for 3 years. We introduced the CX10K in there, and as a result, to them, the switches are practically free, because once they deployed the switches and we deployed the firewall capability for their hosts, they were actually able to recover, over $100,000 in the calendar year, and then save subsequently to that, $150,000 a year for the term of their contract. So over the course of maybe 3 years, the customer saved about $300,000 by deploying the CX10K, and that's just 2-3 rack customer. So the savings are very, very significant.
And I think that's important to note, right? The CX10Ks, right, are switches, right? This is, as Tony said, you could deploy this in your traditional collapsed core. You could do a hub and spoke sort of topology, more maybe more mainstream in the data center. They do all the IP services that you're used to with a standard core or aggregation layer switch. They're marketed as top of rack because that's where they make sense, right? To make the most difference, to be able to pull out all of the bits and bytes and get all the feeds so that they can do their job. But they're switches. At the end of the day, these are switches that you can use in a traditional manner. I think that's really important. I think the K through 12 and higher ed customers, I don't want them to be intimidated by it. This could be a core switch for you. This could be not just a top of rack, and that makes sense, right? If all the layer 3 moves there, then there you go.
So Garrett, you bring up an interesting point. I want to ask Tony about what if I'm not a top to bottom HPE Aruba shop?
Not a problem at all. We use standard protocols that interact and interoperate with Cisco and Aruba. In fact, most of our implementations are almost brownfield, right? Where we can actually add an additional service layer or additional pod subtended to an Arista or Cisco or Juniper network or what have you. And oftentimes that conversation comes up because what we provide is so unique, right? That the customer may not necessarily be in a situation to have a complete network refresh, but there's an expansion that needs to happen, and they want to preserve their assets for the next 5 years, right? Because the generational aspect of what's happening with regards to the TOR is that this type of technology is coming. It'll be coming from many vendors. We're way ahead of the game with the CX10K, and you're just you're basically setting yourself in a proper foundation for building on what the future has to offer by delivering that platform. There's quite a few customers that are doing just that. Perhaps they're not going to deploy the firewall services, but they know that the telemetry and the AI-based applications are coming, and they understand that, and they want to deploy that today with the existing spine.
Well, and just to double click on what Tony just said, I think it's pretty, if you think about it, and Garrett was mentioning this as well, the CX10K is a switch. It just happens to be a stateful switch. And so if you stick it into a stateless network of Cisco, Arista, or Juniper, it's going to work just fine. It's still state, and you can run it as a stateless switch. You can run it like plumbing, just like every other switch, but it has the ability to be stateful. And so you don't break anything when you do that, but your stateless switch that's running all of your standard protocols in your data center is now able to provide you full visibility and telemetry, or it's able to do full microsegmentation and do all that firewall inspection that you're looking for. That doesn't change how you build your data center in terms of your switching fabric. You've replaced your top of rack with a 10K versus what it was before, fully interoperates. And the fact that it became stateful doesn't break anything else either. It's very, very simple and straightforward. And you can move when you're ready. You can insert it, stateless plumbing, do what you're used to, and then begin to implement stateless services on your schedule, not on the vendor's schedule. So it gives you a lot of flexibility, fully interoperates. It can be a full Aruba fabric. It can be a hybrid fabric. It's not going to matter, but you finally now, because at the top of rack is where all these services have to exist. Even if you've got a legacy stateless spine, it's fine, right? You're now going to get all the value out of this stateless the stateful fabric with the 10K now as your top of rack.
Right. And even integration with the tools is relatively seamless, right? Because we use the standard protocols out there for delivering our telemetry, and we also interconnect with most of the customers' standard mechanisms to ingest that stuff. Whether it's a SIM, wherever you're sending your firewall logs to, we can do that. When you think about what we're delivering, is that we have the ability to deliver firewall logs at the TOR, right? And typically, where's your firewall? It's at the perimeter. You're not getting that data, but being able to deliver that at the context of where the data exists is really, really tremendous. And the fact that we can send that immediately to the tools that they're using, it's just a instant insertion point.
I think that was a great point about asking about interoperability with other vendors, because where I see, obviously as a salesperson, I see talking to people who just did a refresh on their closet switches. If I had a nickel for every time I ran into a 4506 or a 6409 or, some old ancient Cisco thing, and they're in the market for a core, like this to me is such a great solution, right? I think this checks so many boxes. Obviously from a connectivity standpoint, there are very few single-use switches that exist on the market that are as good as the CX10K. But I really think that is an opportunity, right? A pair of 10Ks is roughly what one might spend on a new core. Or collapsed core if that's the way you're going to do it. But I think that is a segment of the market that is really undersold this sort of technology, right? Because these people are negotiating whether or not they're going to ask for $100,000 for a pair of firewalls, right? And in my estimation, that's a waste, right? These people, they might have two 500 meg circuits, or they're lucky enough to have two 1 gigabit circuits. Yeah. But to get the necessary firewall throughput to facilitate that many that much internet traffic, more importantly, to facilitate the east-west segmentation they want to run through that firewall, they're putting all this spend, like you said, at the perimeter, Tony. They're putting so much spend there, and it's forcing their hand to really put a lesser technology at the core, or again, top of rack, aggregation layer, however we want to define that. That's where I think the greatest opportunity is. I think in getting those people sold on this, because then they can have kind of whatever, right, at the perimeter. Whatever they're currently doing today, they don't necessarily have to buy a pair of big monolithic firewalls that probably have 25, 40, or 100 gigabit interfaces. That is a waste at that point, right? If this was their core or their top of rack solution, I think it checks a lot of boxes, and it fixes a lot of people.
Yeah, that's a very common use case actually across our commercial sector. So you're spot on with that.
So Scott, I know this is a unique approach by HPE Aruba with AMD Pensando relationship, but I believe there's other vendors out there who offer services similar to this. Is that true?
I think the marketing is very interesting, I guess, in this space, Tom, if you want to think about it that way. All switching vendors in the data center have had to try to have a conversation about inserting services and how do they insert the right services, which when you think about it, they're trying to simplify bolting on stateful services to their stateless plumbing fabric is what they're trying to simplify, automate, streamline. The difference with the 10K is very fundamentally different than that. The 10K is the service, right? It isn't plumbing that's trying to trombone to some large firewall sitting in a services border leaf to insert and bring it back. And I get why we did that 10 years ago. It's all the tech we had. It's not 10 years ago anymore, right? So it's today. We can do things much more intelligently. Silicon is more capable today than it was 10 years ago. So I don't need a 10-year ago solution when I'm trying to solve problems today. The 10K is the service. We're not trying to insert or bolt it on or automate it. Fabric grew up, right? This isn't your father's fabric any longer. So the 10K is able to be stateless plumbing. The 10K is able to offer full visibility and telemetry, very difficult to do. It's also able to provide full microsegmentation. I don't have to go find the firewall. I am the firewall. And so while marketing and messaging can definitely confuse our customers, the fundamental difference is every other switch out there in the data center is trying to go find and bolt on a stateful service. The 10K is the stateful service. And so we don't have to go find it. We don't have to bolt it on. We don't have to add an operating system, add a GUI, add something else to update, more swivel chair management. All that goes away. It's simple. It's again, if you want to know what an enterprise data center is going to look like, look at the hyperscalers and add 10 years. This is what the hyperscalers look like, and they have looked like for the past 10 years. The 10K is that. So it's time for the enterprise to finally be able to embrace the same technology that has made the world's largest data centers the most stable and simplest data centers. Now they get access to it.
Scott, Tony, Garrett, thanks a lot. A lot of great information you've shared on this exciting new architecture solution in the fourth generation of switching. Garrett, how do people reach out to Zunesis to find out more about the HPE Aruba portfolio and specifically the Aruba 10K switch?
Yeah, you can go to our website. It's zunesis.com. Obviously, Zunesis is spelled like right by my name. And feel free to reach out to us. We're happy to interact with any size customer. And we have a great relationship with all the engineers at Aruba. And we're excited to work on the opportunity to work with people on the CX 10Ks. I think it's a pivotal change in data center technology, and I think it's going to make a big difference for people.